So continuing on with why the sky is blue, I need to tell you a little bit about white light now. And there's a very famous picture which you may have seen before in one of your science classes, maybe from high school or elementary school. This is the famous scientist here, Isaac Newton, and he did a lot of experiments with all kinds of science. But one of the things that he did is he closed up his door of his laboratory, and you see some of the white light from the sun streaming in. But on one of the holes right here, he held this object that's, of course, known as a prism up to the light. So in his hand here, there'd be like a triangular piece like this that the light went through, and it sort of streams across the room. And what he realized is that when the prism encounters light, it makes all the colors of the rainbow come out right here. The rainbow all comes out. In other words, when we look at the colors there, we see the reds over here, we see a little bit of the greens in here, and we see the blues down there. And that's that full spectrum of the rainbow. And he was the first to see then that what white light is here. So if you have something like this white light, what it really is all of the colors all bound up into one. So you will have blues in there, you will have reds in there, you will have greens in there, you'll get the oranges in there, and all these colors, maybe even like darker blues in there, but you get all of the colors in white light, and that's what white light is. So white light is very much made of all the colors that we're used to seeing. So that is one of our final sort of needs or facts then on where this blue sky comes from. So here you go. Here you are down on Earth, and as we know now, I won't draw them. Well, okay, I'll just draw them. But here's all the nitrogen, oxygen in the upper atmosphere. And then what happens is white light comes in from the sun. I'll stop it right there and draw it in terms of its constituent colors then. So in this white beam, there'll be some blue, there'll be some green, and there'll be some red. And in a couple of videos ago, we even assigned some numbers to these here. The blue is 420 nanometers. The red is something like maybe 700 nanometers, and the green here is maybe something like 550 nanometers. We even know the wavelengths of them, but here's what happens when they start to encounter these molecules. If you're red, you just keep on going through. Not a lot happens. If you're green, not a lot happens. You just keep on going through. No big deal. But if you're blue, if you're blue light and you hit one of these nitrogen molecules up here, you're going to get this nitrogen molecule to start moving like crazy, and what's going to happen then is blue light is going to just go in all directions like this, all directions. So let's draw another blue beam coming in like this to hit this molecule right here. Bang! And because you're blue, all this blue light's going to go in all directions like this. Let's have another blue beam coming in like this, hitting that molecule right there. Bang! All this blue light's going to go in all directions like that. And I hope you're seeing where this comes from now. And so what this is called scattering. And you can see what happens now. Here you are down here on Earth, and you're sort of looking up at the sky. And of course, because these nitrogen and oxygen molecules are scattering this blue light in all directions, including this way, let's not forget some of it still will go forward, no big deal. But a lot of it then is going to come down into your eye. And that's it. After all that, after all those videos, that's why the sky is blue. Let's see if we can capture it maybe in one final summarizing sentence. The blue sky. Oh, how do we want to say this? We can say N2 and O2. In our upper atmosphere. Scatter only blue light from the sun. And I'll just leave it at that. Okay? Read it one more time and I'll sort of point out some of the key words here. Nitrogen and oxygen, key players. If they weren't there, we'd have no blue sky. In our upper atmosphere, so way, way, way up in the upper atmosphere where it's very wispy and hardly breathable, and you saw that spacecraft coming in, they scatter. Scatter is a very important term for this because what that implies is it sends in all directions. Sends in all directions. And what I mean sends, of course, sends the light in all directions. That's what scatter means, but not all the light. As you can see here, the red goes forward, the green goes forward, and the orange will go forward. But if you are blue light, you'll get scattered the most. And of course, the sun is what's generating it all. So you can really think of the blue here as our maybe sun illuminated atmosphere. Sun illuminated atmosphere. So when the sunlight illuminates our atmosphere, it looks blue to us. And so I'll just conclude this video by just drawing that figure one last time with just the key essentials, so we have it all straight. I think it's also just a really nice figure to see because of all the colors that I have available on this tablet here. But there you are, okay? And you can go ahead and draw some little wisps of nitrogen and oxygen in the upper atmosphere. And then what you can do is you can draw red light from the sun going straight by because the molecules don't care about red light because of their structure. You can draw green light going by, and it's just going to go right by because the molecules don't care about it because of their structure. And you can draw orange going by, and you can draw yellow going by. All of these colors are just going to go right by because the nitrogen and oxygen don't care about them because of the structure that they have. But suddenly, when some blue light comes in and hits the molecule like that one right there, you see this scattering going in all directions like that. And here's another blue beam coming in, hitting that molecule right there, scattering in all directions like that. And here's another light ray coming in, a blue one, bang, hitting that molecule right there, scattering, going in all directions. So there's always a nitrogen and oxygen molecule right there at those scattering centers. And then here comes the blue light from the scattering down into our eyes. And so when we look up, we see nothing but the blue. We don't see the reds and the orange and the greens and the yellows. Those are going right by. But it's the structure of those nitrogen molecules which drives the whole operation. And so there you go. There's your blue sky. That was a lot of work, though, all the charges and the molecules and all the reasoning. But that's why the sky is blue ultimately. So hope you got that.